Hello everyone, welcome to Chemoholics, your one-stop channel to make chemistry simple, easy and exam ready. In this series we have been talking about Geochemist Exam and I have taken paper 3rd part A where we are going to solve the questions from analytical chemistry, and right now I am taking the numerical problem from paper 2017 to 2025, whatever paper question has come in this paper. So today I have bring one more interesting numerical problem from Geochemist examination, and this problem came in 2018 paper and it has 10 marks. It is a 10 marks question. So let's see what they are asking in this question. So let's read the question first. A mixture of HCl and H₃PO₄ is titrated with 0.1 molar of NaOH. From here we can clearly see that it's a question from acid base titration, right? Acid base titration. Second, it's not a simple acid base titration, but they have given mixture of two acid. One is HCl and second is H₃PO₄. And remember, HCl is more acidic as compared to H₃PO₄. It's monoprotic and it's triprotic, and when it's triprotic it's going to give you dissociation of proton in different step, like H₃PO₄ is going to give you H positive plus PO4 minus. Then this H₂PO₄ is going to give you another proton, H positive plus HPO4 minus 2, and again this is going to dissociate to give you H positive plus PO4 minus 3. So this is how it's going to dissociate, and in each stage and each dissociation stage it is going to show you a different pH. Remember, different pH, and this is the basic part of this question. Now let's read another part of the question. The first endpoint, methyl red, occurs at 35 ml. Now what is the meaning of this first endpoint? What is the meaning of this first endpoint? First endpoint means HCl, which is a strong acid, is going to neutralize completely. By NaOH, okay? As well as the first proton, this first reaction is also taking place at this stage. PO4 is also going to be neutralized first proton, only first proton by NaOH, okay? So this is the meaning of first endpoint, that HCl is going to completely neutralize by reacting with NaOH, and first proton of this phosphoric acid is going to be neutralized by utilizing NaOH, okay? Now let's read again. And the second endpoint, bromothymol blue, occurs at total volume of 50 ml. Okay, now what is the meaning of this second endpoint? As I told in this, HCl is neutralized completely at the first endpoint, and H₃PO₄ is going to dissociate in different stage. At first stage is already completed, first endpoint. Now what will happen in second endpoint? This is again going to dissociate into second reaction, giving second proton. So H₂PO₄ minus is going to dissociate again in between first and second endpoint to give you H positive and H H₃PO₄ minus 2. So this is the second endpoint. Now have you seen in this question that they have given two different type of indicator? One is methyl red and second endpoint is appear by using bromothymol blue. So I will explain you a concept about this as well. See, during first endpoint, because HCl is strong acid and initially this H₃PO₄ is also a strong acid, so both also behave as a strong acid. So at this point the pH is generally going to be below 4 or even more below or even very low. So below 4 the methyl red is going to give you a color of red, but once this neutralization takes place this pH is going to increase is going to be greater than 6.2. So at this point the red color of methyl blue is going to change into the yellow color. This is the indication that your HCl and H₃PO₄ is completely neutralizing. But after that there is no use for methyl red. So to find out the second endpoint we need a different type of indicator. So here comes bromothymol blue. Sorry. So bromothymol blue, see, at pH around 6 this is going to be give a yellow color, but again when this is going to be neutralized the pH is going to increase further and obviously it is going to cross the pH range of 7.6, and once this 7.6 pH range is going to be crossed the color of the solution is going to become yellow to blue. So here three color changes you are able to observe. Initially it's going to give you a red color, okay, at that time HCl as well as H₃PO₄ is present in the solution, and once HCl and first proton of H₃PO₄ is neutralizing, it's give you a yellow color which is indicating the first endpoint. And after that for second endpoint where only the remaining this H₂PO₄ negative is going to be dissociate into proton, so this will be indicated by change in yellow to blue color, which is going to be indicated by bromothymol blue. So I think up to this point you will understand what is the meaning of first endpoint and why methyl red is used, and what is the meaning of second endpoint and why bromothymol blue is used. Now let's come to the main question, that what they are asking. Calculate the millimoles of HCl and H₃PO₄ present in the solution. So by giving this they are asking that initially how much HCl is there and how much H₃PO₄ is there. So let's solve this problem, and they have already given you the concentration of NaOH, but they are asking in millimoles. So we need to convert the concentration into millimoles. So as you can see from here that whatever amount of NaOH is used is equals to the amount of HCl and H₃PO₄. So we are going to solve this by volume calculation. So let's see, concentration of NaOH is 0.1 molar, right? And we need to convert it into millimoles because they are asking an answer in millimole. So how we are going to solve it? We know the molarity, formula of molarity. Formula of molarity is what? Moles upon volume, and here volume is in ml, so we can multiply it by 1000, right? So we need to calculate the moles. So how you are going to calculate the moles here? So moles is going to be like molarity multiplied by volume in ml divided by 1000. Okay, now where you are going to get this volume? Now here molarity we have 1000, we don't need 1000 is constant. We need to calculate what is the volume. See, in this question the first endpoint is at 35 ml. So here we are going to use 35, first endpoint is at 35 ml, right? So in this 35 ml we are going to calculate how much millimoles of NaOH is there by utilizing this formula. So moles is equals to 0.1 multiplied by 35 ml divided by 1000. It's going to give you 0.0035 moles, but in question what they are asking in millimoles. So let's convert it into millimoles. So when you shift it here, it is going to be 3.5 millimoles, right? And in this 3.5 millimole, just like I told you, at first endpoint both HCl is also there and H₃PO₄ is also there. So we cannot calculate the separate millimoles of HCl and H₃PO₄. So this millimole is for HCl as well as H₃PO₄. So we need to calculate either this or this, so that we can subtract it and find the millimoles of second element. So now comes the second endpoint. At second endpoint only H₂PO₄ is dissociating or reacting with NaOH. So if we calculate this amount, we can subtract, because whatever amount of, if it's X, it is also going to be X, let's say. Okay, so we need to calculate its amount. How we are going to calculate it now? Now second endpoint is 50 ml. Look, here is the point. You should not utilize 50 ml, because up to 35 ml we have already calculated the amount of NaOH that is used. After that we have only added 15 ml of NaOH. So we only need to calculate the amount of NaOH in the remaining 15 ml. So second endpoint, so we need to calculate millimoles of NaOH between first and second endpoint only. Okay, how we are going to calculate it? Use the same formula. Moles is going to be 0.1 multiplied by, the remaining is 50 minus 35, is going to be 15 ml divided by 1000 is equals to 0.0015 moles, or we can say 1.5 millimole, right? So this is the amount of what? H₂PO₄ minus, or we can say this is also amount of H₃PO₄. So once you find out the amount of this, you can calculate the value of HCl. So millimoles of H₃PO₄ is equals to 1.5 millimole, and now we can calculate the millimoles of HCl is going to be 3.5 minus 1.5, it's going to give you 2.0 millimole. So this is the final answer of this numerical problem, that how you are going to solve it. So I hope from this question you have understand the concept of indicator, why we have used two types of indicator, and how we are going to solve this problem, and how we are going to calculate the concentration of both the acids. So with this I am going to end this video here. Stay tuned for my next video with new problem. Till then, bye bye, and thank you so much for watching. And if you enjoy this video, please do not forget to like and comment what you want to learn more from me, and please subscribe the channel and share this video to your friends.